All right, folks, welcome back. Today is going to be a demo day, and is going to be split in two parts. In the first one, we're going to explore more Android emulators, AVDs, and share commands on how to interact with with these emulators and so forth programmatically. And the second part, which I'm going to record later today, is going to be about reverse engineering. So I basically prepared a simple app where we need to find the flag. So I'm going to present the scenario. What does it mean to find the flag? And I'm going to show four different ways to solve it. So different approaches. Okay. So again, this is going to give you ideas on how to approach the actual challenges for the second homework, which is going to be coming next on reverse engineering. Okay. We're still in first homework period, so don't freak out about the second one yet. I'm gonna give more details later on via email. Okay. All right. So let's get started. This app that you're seeing here is the one I've been using so far. So there is nothing in particular. There is just one main activity that can start the second one. What I want to focus as of now is more starting emulators and see how these emulators are actually start under the hood. So I've shown in the past how to get to this view, tools, and then AVD manager. Oops. And AVD manager. And in AVD manager, basically you have the list of emulators that you have. And I think in the first class, we've seen how to create a new one. Now, these things are actually exposed also from the command line. And I want to show you now how to get it. So we go to another view. Oop. This is just a shell. And I went to the Android SDK. This is the content of Android SDK. And this is basically where the SDK is actually stored. And again, I've shown in the past how to find out where the SDK is installed on your machine. So if you have Windows or Mac OS, it's going to be a slightly different path, but it should be easy to actually find it. Now, the emulator is not a magic. It's actually a program, a very complicated program, but it's still a program, okay? And where is it on your machine? Well, Linux, we can type find name emulator. So emulator is the actual name of the program that runs the emulator. Wow, crazy name. And as you can see, this is, I think, one of the latest versions of Android Studio. You can see there are three different emulators. I mean, this emulator is the actual folder, and these three are actual files. This confused me a bit, so pay attention. The real emulator binary is the one in the emulator folder. I think that the tools emulator, I don't know what it is, to be honest. Maybe it's the real binary, but it's called by this emulator in some kind of a wrapper kind of way. But the actual one we're going to use, and the one that is suggested using various documentation, is the one in the emulator folder. So we go in the emulator folder. Again, there are a bunch of things. We are interested in this emulator, and this emulator is based on Chemo, and my understanding is that it's actually a modified version of Chemo. I think to improve stability or to introduce Android specific things. And again, it's a binary. And give me a second. We can do emulator, and then it's going to complain. Okay, so it's not extremely user friendly, but you can actually do help. Attention is not dash help, is dash help. And then, oh, there are tons of different things. So this is actually a very, very complicated program. Turns out to just start an emulator is not super complicated. And the first command I want to show is the list AVDs. So we can do emulator dash list AVDs. Again, if you check the actual help that I've just shown, it's there. But of course, it's like, under the sea of all the other commands. And what it does is to just dump the AVDs that are created on your machine. Okay, so basically this is the command line interface of the nice AVD manager that you've seen before. Okay, now once you have this, you can actually decide to start an emulator again from command line. Emulator, and then the way it works is you need to decide which one to use. We're going to use zoom num. That's the one we created together. And the syntax for this is at and then zoom num. And I'm under the sky and looking up for the gods of the demos. I hope it's going to work. If I press enter, bam, it actually worked. So we've seen how fast it is and how simple it is. Okay. Why am I showing you this? Well, it's not necessary, right? You can go on the main command line, user interface. You have AVD manager and start it. I'm showing this because I want to show you a little bit under the hood how things work, and maybe in the future you need to somehow write some automatic system that maybe spawn an emulator, restore an application, analyze it. The one basically that you've been using for the first homework, and that's how it actually works under the hood. Okay, good. So that's the first part. Once it's up, then I've shown in the past. Let's create a new tab. Shown in the past how you can use ADB to actually interact with these kind of things. So first of all, we can do ADB devices. In this case, there is only one device. Again, a device can be an emulator or an actual device you connect through USB. And since here there is only one device, if we issue a command like ADB shell, well, ADB knows to which emulator or to which device to get a shell in, because again, there is only one. If you have multiple emulators, then you will need to specify to which one. So there is an option in ADB. I actually don't remember what it is. I think maybe the chess to indicate the serial number of the device you want to connect to it. But again, I'm not completely sure. But basically, there is a way to select, in which device you want to get a shell. Okay, good. We have seen last time ADB, ADB load cap. Okay, that's how basically you get what's going on in the system. And if you use the log command, the log API in the Android app is going to show up here. Of course, it's very noisy. So what I usually do is to log with the tag that is very specific, like MOBISEC, and then we do ADB load cap grep MOBISEC. And you're going to see only the messages related to MOBISEC tag. Okay, so again, that's what I usually do. On the app analysis system for homework 1, what I do is to actually grep for MOBISEC, and I only show you that portion in the public traces that you're going to see after you submit the app. Okay, but again, under the hood, that's how it works. Nothing is magic. All right, another thing I want to point out is that you're going to see now in this demo a number of commands that start like this: ADB shell, for example, and ls. Okay. And bam, we're gonna have basically the files inside the emulator. Okay. So what I want to stress is that when you see me doing ADB shell ls, this is equivalent to doing ADB shell and then ls. Okay. This actually is the same output, except for some new lines, but it's actually what's going on. I'm saying this because sometimes you see commands, weird commands like ADB shell PM, for example, that you're going to see now. And you may be wondering, what is PM? What is it? Well, PM is actually just a program implemented inside the emulator. So if you do ADB shell PM, you're just invoking a program inside the emulator. Okay. And again, there is PM for package manager, there is AM for activity manager, and so forth. And we're going to see a bunch of them today. Okay, so to explore a bunch of other commands, we go back to the Android app. We close this and we compile it. Build the VK. Okay, it's building it. Good. So we try to find where it is, and it should be always at the usual place. Android Studio project, and then it was Zoom, no, MOBISEC, Zoom enable, then it was up, build outputs, APK, and it should be the bug, and it should be, oh, there was mess. I think it's going to be, yes, November 2nd at this time. So this app-debug.apk is the one we just created. The first thing I want to show is how to install and uninstall an APK. Okay, I don't remember if I showed it already. Okay, if I did, it's okay anyways. So the way we do it is adb install app debug.apk. Okay, bam, we just installed it. And then I want to show you how to uninstall it. Now you may be tempted to do something like this: uninstall it, app debug.apk. This tab does not work. The twist is that uninstall wants a package name. Okay, so what is the package name of this app? Well, let's figure it out. One way of doing this, we check the manifest, and it was this guy. So adb uninstall and success. Okay, so now you know how to programmatically, let's say, install and uninstall an APK. Good. Other two commands are push and pull. I think I mentioned them in the slides, but I don't think I ever showed them. So let's do this. Let's get one, first of all, a shell. And let's get a shell maybe in the, let's go in the SD card. So these are the files in the SD card. And now what I want to show you is how to maybe push a file from your file system, from your computer, to the emulator, and how to pull one file from the emulator to your file system. Okay, so let's create a file that contains live demo in live demo. So, okay, if we do cut live demo, you're gonna see it. And then let's do adb push live demo, and then we specify the destination, SD card, live demo. Bam, if we do ls now, we're gonna see live demo, and we can cut it. Okay, it's there. All right, so vice versa, let's say we are inside the emulator in emu, and let's write in emu. Great. Now let's say there is a file that it was produced by an application in your emulator, and you want to get it out and maybe analyze it maybe on your machine. Let's try adb pull SD card in emu, and then you put it in emu. And again, I think it worked. Bam. Okay. So now you know how to push and pull a file. Great. Now, in the previous class, I've discussed how you may want to get the APK related to an application that you want to debug. For example, the Facebook app. For example, any other app that you may install from the Play Store or from any other source, and maybe you want to start reverse engineering, as we discussed in the other slides last time, where and how you do get the app. Okay, so last time I discussed two scenarios. In the first one, you have the Play Store app already installed on the system. That's what happens with normal devices. Let's say on the Play Store, you can log in, and then you can search for your application, and then you're going to say, okay, Facebook, and then you can say install Facebook, and then the APK is going to be installed there. If you have an emulator like the one I have, with this one was without Google APIs. The advantage is that it is rooted. And so, for example, we can do zoom, and actually fascinating. This is actually not rooted. So more interesting. So if it's rooted, then you would have zoom. Sorry, if it's without the Google APIs, you would have zoom. If it is with Google APIs, you don't have zoom. And actually, that I noticed, you see here the Play Store app. So clearly, this is the emulator is not is with Google APIs, which means it's not rooted. Okay, and let's say that you installed an app. How can you actually know where the APK is on the device, and how can you get it out? Well, how can you get it out? Once you know where it is, it's actually simple. Now you can do adb pull and then the path. But as you remember maybe from last time, finding the actual location in the emulator where the APK is may not be super trivial. Okay, so what we do is the following. First of all, there is a command to list all the apps installed, and we're going to list the package names. Okay, and I think the command should be the following: pm list packages. Then this is the list of the package names of all the apps that are installed. Not only the apps you install manually, also the apps that are part of the Android system. Okay. As I mentioned before, you can do the same command by doing adb shell pm list packages from outside the emulator. This is the equivalent of getting a shell in and do pm list packages. Okay, that's the same stuff. Now, since so let's simulate that we installed an application from somewhere, and of course the assumption is that we know the target package name. And how can you know the package name of an app you just installed from the Play Store? If you check the URL of the Play Store page of a specific app, like Facebook, the URL is something like Play Store, I don't remember, play.google.com / I think it's ID equal and then a string. That string is the package name. Okay. So again, we're assuming you have the package name and now you know how to get it. Let's simulate this kind of extraction APK with our toy application. So first of all, we restore it again. Okay, now we knew the package name and it was something like MOBISEC zoom node demo. And so we do this adb shell pm list packages, packages grep MOBISEC. Okay, so it appears here. Okay, now we can do another command to find the path where the APK is on the emulator given the package name. And the command should be the following: adb shell pm, I think it's path, and the package name. Fantastic. Okay, and this is actually the full path. And again, these commands work without the rooted emulator. Okay, and again, that's emulator. This emulator is not rooted, so I'm not cheating here. And once you have this, you can basically take this guy and you can do adb pull, and we call okay base APK. Bam! Now we have a base.apk on our machine. Okay, and I think actually it should have. Just want to. Yeah, this is exactly the same file that we installed. Okay, so again, if you install Facebook, Facebook is gonna have a very specific package name. You do this kind of command, pm path Facebook, katana, whatever it is. You get the path, you can install the APK, and bam, now you have the APK. And you can apply all the techniques that we discussed last time and we're gonna show today in the demo. Okay, great. Let's move on. Okay, so the next thing I want to show is how to start an activity from command line. And that's something that some students were wondering, or how does my system work? Well, when you submit an app to my system, what I do is to install my target app, if any, install your app, then I start my target app, and then I start your app. How do I start the app? By starting the main activity. And how do I do this? Well, we use the program AM, which stands for Activity Manager. And you can use this in the following way. I think it's ADM shell. Okay, again, AM start. Basically start for start activity, and then the chain you specify which component you want to start. Okay, and this is not necessarily the main activity. I'm going to start the main activity, but you can also start whichever activity you want. Of course, there are some permission checks. If the activity is not exported, you cannot start it. If the activity is exported, still maybe you can start it, but maybe it's gonna crash, depending on if the second activity was expecting some context. So it's not gonna always work, but technically you can start the activity. And then what we need to provide is the target. And the target, we need to have the package name of the target app / the package, basically the name of the component we want to start. The name could be either the fully qualified one, where we have package name dot, the name of the component, like main activity, or if the package name corresponds to the package name of the app, we can do like dot main activity. Okay, and that's what we're gonna do. I do not remember the package name of this guy anymore. It was this guy. So what I want to do is to start the main activity of our test app / dot main activity, and if it works, we should see something on the emulator. Bam! Incredible! I am on fire today. Okay, so once again, it worked. Good. Another command I want to show is how to grant permissions. Again, some students asked me, how is it possible that once I ask for location permission and you submit it to my system, how is it possible that the application has the location permission even if the user didn't say yes? Well, because I'm a nice guy and I don't want you to go crazy. And some of the challenges that I developed assume that you can have these permissions. So what I do is that I take your APK, and if your APK defines in the manifest, well, use permission, I don't know, location, then I get this thing from the manifest, I think using this AAPT command that I've shown, I think, last time. And then I run something like this. The shell, I think is PM, yes, grant, and then it's package name, and then the permission. So I don't remember the actual name, but it could be permission.location. You press enter, bam, the target app has the location permission, and the user doesn't need to say yes. Okay, is this a bug? Of course not, because an attacker cannot actually get an ADB shell on your phone and then run this command. If you could do this, then the attacker has many other, probably the fact that you may lose location is the least of your problems. Okay, so that's why it is there. Okay, I have another command I want to show. It is dump sys. Again, these are all binaries inside the emulator. Okay, dump sys. Bam, it's a lot of crap, and I was actually not expecting this much. And this dump sys, let's see if there is an help. Yes, basically it dumps the status information, and basically you can specify what kind of service you want to dump information from. And I didn't use it that much in the past, but I did use it for dumping the UI related information. So there is a way. Let me see this. Head. Okay, this is the list of services. And basically, you can get some information from there. Do you remember if there is a UI service? No. Maybe display. I don't know. This is kind of, yeah, I think it was this one. And basically, you can show maybe the current activities that are displayed, the various views, their location, and so forth. This kind of a low-level tool. I just want to show you, if you want to dump some information, maybe it's already available through this dump sys, but as you can see, I'm not super familiar, and I don't remember this stuff off the top of my head. Good, but it's there. Sounds good. Okay, we did an install. We did install. Okay, so yeah. So let's get another shell. Okay, and here we can see, we have seen there were two. Yeah, I cannot do ls because the thing is not rooted, but we've seen last time that there are two main folders, /data/data, and then /data/app. /data/app is the location where the APKs are stored, among other things. Okay, /data/data is a place where all the internal folders of every application is stored. So we discussed in the past, if you store an application X, this application X is going to have its own user, Linux user ID, and it's going to have a private folder. This private folder usually lives in /data. Yep. And one thing I want to show before we move on this is something weird. If you do list packages, you're going to see a bunch of things like, comma entry calculator, all the apps that are installed, default, non default, are here. And something weird is that there is an app, apparently, it's called Android, whose package name is called Android. Okay. So remember this, we're gonna get back to it. And then, you know, it's very interesting. There are all the different components of that somehow build your phone are actually here. Okay, like YouTube and so forth. Okay, so moving on. I would like to move on a bit on these signature things that we discussed in the past for the APKs. And okay, so let's take this basic APK. Let's say that we got an application, so we have basic APK, and let's open it up with APK tool or the show base. Okay, base. And then I want to show this part, original and meta info. I've discussed these files, cert.rsa, cert.sf, manifest.mf, in the past, discussing that, you know, each application is signed and that each, you know, it's signed with a specific private key. You don't have the private key, what you have is a certificate. So it's containing the public key and some metadata. And from this public key, somehow you can infer some properties. One of the common misconceptions is that this public key or this certificate somehow is able to tell you, oh, this is a real Facebook app, you know, the analogous of what happens on the web, where you can go on https://facebook.com and somehow the green log tells you, hey, this is the real Facebook. On Android, it's not like this. If you have an app with Facebook Katana and then it's signed with some certificate, and the certificate maybe even claims I'm Facebook, you cannot really trust it, okay? You really need to take this public key and you need to compare it with the real public key of Facebook to check that it's actually the real Facebook, okay? So this information is not embedded there, and there is no really chain of trust in a sense that the certificate that is signing this application does not need to be signed by any of these trusted certificate authorities, okay? Good. What I want to show you is how to dump this kind of a public key and how to dump the information contained in this certificate. Why do I want to show this? It's going to be clear in a second, okay? So let's take this certificate and let's try to dump it. And the command to dump it is the following. This is in der format, DER, and you can do this. Again, this command is in the slides, pkcs 7 in shared RSA. This is the file, and then we tell OpenSL how to, you know, what's the input format, and then we say please print it. Okay, so it's a bunch of information, and then you can see, you know, some meta info like which algorithm is used for signature, for hashing, blah blah, and then some of the issuer. Was the issuer Android debug something? That's the app signed by the certificate in Android Studio. That's why this debug stuff. And this is the public key, okay? And the public key, of course, is uniquely associated to the private key. And you know, if if two apps are signed with the same certificate, in a sense, with the certificate with the same public key, then you know these apps are from the same authors. And I'm stressing this point because, as you may remember, this is signed with the same certificate as this other app is very, very important to understand the signature permissions, okay? So remember, signature permissions are usually you know, very, very powerful permissions, but it's not that if a permission is signature, then it means it's very powerful. That's again a common misconception. So what happens in Android is that if a permission is signature, just means that an application, to get this permission, needs to be signed by the same certificate that signed the application and defined it. Okay, so Facebook, can create an app and define a permission, like declare its existence, which is very different than using it. Okay, so I can declare the existence of a permission and I can assign the value permission level signature. This means that another app, to get this permission, needs to be signed by the same certificate that signed this Facebook app. in practice, it means that other apps of the Facebook ecosystem, so signed by Facebook as a company, can actually get this permission, but not everybody else. Now, the common misconception that signature permissions are very powerful is because in Android, of course, many of the very powerful signature permissions are signature permissions. And I discussed last time that in some documentation, you can see that these signature permissions are considered system permissions. So what does it really mean and why I'm talking about this? Well, these signature permissions are basically declared by a main important app in the Android framework, okay? And whoever is signed with the same certificate that signed this very main important app in Android framework, then can get this signature permission. So the very definition of being a system app actually comes from, are you signed with the same certificate that signed this very, very important central app in Android? So today we're going to see what is this very, very important app that is so central to Android. So the app that we're talking about is the app whose package name is Android. So we've seen 2 seconds ago, shell pm path, list packages, that there is an app called whose package name is Android. This app is fundamental in Android. This app, again, is the root to define whether another app is considered system or not. If you're signed with the same certificate that signed this guy, great, you're a system app, okay? And the other trick is that all the signature permissions, things that you're not supposed, that a third-party app cannot really have, that are flagged with the permission level signature, all these permissions usually are declared in this Android, in this app whose package name is Android, okay? And so automatically, basically, you can get the signature permissions only if you are a system app, only if you are signed with the same certificate that signed this main Android application. And so what I want to do now is to actually extract the APK whose package name is Android. And then we're going to see its manifest, and we're going to see that, yes, actually all these permissions that we know are actually defined there. And then we're going to get one app that is considered, a system app. Maybe you can get the app related to the UI that you see, which is a system app. And then we can see that, hey, this is signed with the same certificate that signed the Android app, okay? Or this app whose package name is Android, okay? And we are going to do this step manually, but that's how the system works. That's how the Android framework understands, hey, you have another app now, and yes, I can consider system. And if this app asks for permission X and Y, and this X and Y have signature permissions, then I'm going to allow them because this app is signed with the same certificate as Android app. Okay? So let's get to it. So we do adb pm path Android. This is to understand where the APK related to the app whose package name is Android located in the system. Fantastic. Okay, the error is simple. Bam, this guy. So somehow this is the path of the APK that is the root of all this system definition, and that's the one that implements and declares all these intents, all these permissions. Okay, so let's try to get it. So let's create a folder, system test, and we'll do edit pool, and this guy, edit pool, bam. Okay, now we do APK tool, the framework. If you don't use the -o option in APK tool, it's just gonna create a folder with the same name of the APK. So in this case, it would be framework-res. That's a shortcut. All right, framework-res, bam. What you're looking at right now is the core Android app that really implements all the permissions. And look at this. This is the Android manifest. Kind of big, right? So let's open it up. And really, it's okay. This is not permissions, but let's try to permissions. Bam. Look at this. This is declaring a group, permission group, about the contacts. And then check this out. This is declaration of permission, read contacts, write contacts, blah, 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 blah. Okay. And then you can actually grab for permission level, what's the name? Protection level, sorry. Signature. Bam. And now we're going to have some permissions with, you know, network stack and so forth. These are all permissions with signatures, with level signature. Okay. And again, these are all the permissions that you can request with your third-party applications. I mean, not the signature. I'm talking about, you know, for example, the contact permission, and that's where they are defined. That's where the Android framework understands, hey, there is a permission, the permission is this. So when the Android developers actually need to implement a new permission, they're going to add one entry in this manifest file. Again, please do not be confused. When you in your app request a permission, usually use the tag uses permission. That's when you want to say, I want to use permission X. In this case, we are not doing uses permission. Check this out. We are doing permission something. If you check the initial slides, this is a declaration of the existence of this permission, and is the declaration also of the protection level. So if it's normal, then if your app just asks for it, it's going to be granted at installation time. If it's dangerous, there is going to be some pop-up. If it's signature, again, the certificate rule kicks in. You're going to get it only if you're signed with the same certificate that signed this app. Okay? Awesome. So now I want to, let's get another application that is a system. Let me see if I sign up some cool name. Yes, for example, the app implementing the UI. ADB, but okay, let me do this. Hopa. ADB, shell, PM, these packages, grep UI. Okay, system UI. Let's find out where it is. Awesome. And let's get it out. Sure, let's come here, perfect. ADB, pull. Awesome. APK tool, the system UI. Okay. System UI, bam. Now, okay, just let's check the manifest. Again, it's huge. Now you're gonna have use permission, okay? I don't know if you're gonna see it. Let me move my face here. You're gonna see, oh, look at this. Use permission, Android grant runtime permission, revoke runtime permission. This seems pretty important permission. Let's see what's the protection level. So let's reopen the manifest of the framework and let's grab for grant runtime permission. Bam, protection level signature. Okay, which means that either this system UI app is signed with the same certificate as signed Android app, or is not gonna get it. Now, since it's a core app and since probably they didn't screw it up, this app is actually gonna be signed, signed by the same certificate as signed Android app. And now we can basically dump this the certificate that signed both apps, and the public key should be the same. And if they're not, then this demo is a terrible failure. Okay, open SSL, bam, there's the same command as before. And original meta info, open SSL. And please, 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 let them be the same. And they are the same. I mean, it looks like 30, 82, 01, 08, blah, blah, blah. And then it finishes with 0301, 78 to be 81. Yep. Okay. So that's why the system UI can ask for this, for example, grant permission at runtime permission, but your third-party app cannot, okay? Because you are not signed by the same certificate. Cool. And that's about it for this part of the demo. The only command that I have listened out that I also want to show is if you have an APK, how to verify that the signature matches, so that is basically validly signed APK. And the command is the following: APK verify. APK verify, and the name of the app, the APK. Fantastic. I cannot find it. Okay, let me see where it is. Android SDK, find APK verify. Oh, sorry. It's not there. Okay, I have no idea. I have absolutely no idea where it's supposed to be. I think it's maybe left over some old version. I'm pretty sure this command still exists, and I'm maybe gonna write via email when I find it out. Okay. If you find it, let me try maybe some find name verify. Nope. I don't know. Check documentation, figure it out. Google for it. You're gonna see that there is a command called like this, and it's basically gonna tell you, okay, this file is okay. The signature somehow is a valid one. Otherwise, it tells you no, the signature is broken. Okay, and if it's broken, well, maybe you should pay attention. And if you try to install it, the emulator or the device is gonna reject it anyways. Okay, so you cannot install something that is not you know, whose signature is not valid. Okay, and that's basically it for now. And in a bit, I'm gonna record the other demo on debugging errorless engineering. Okay, and let's see if I can stop the recording. Yeah, see you in a bit.